In this video, we're continuing our look at review problems from Unit 3, Continuous Probability. In this exercise, we have a ticket booth that's open from noon until 2 o'clock. Assume that customers arrive uniformly during the entire period. We'll say that's 2 o'clock p.m. Let X be the time in hours from noon for the arrival of a random customer. So X can range anywhere from 0 to 2, and it's uniform. Okay? So, work out these two problems, the probability that X is less than 1.25 and the probability that X is greater than 1.5. Work that out now. Well, the graph, that's a little hard to see here, but less than 0, it's 0, so we got to on the x-axis here. It's also on the x-axis over here once you get to 5, from 5 over. In between, we have a horizontal line. Now that rectangle, not the one I have shaded here, but all the way up to there, has to have area 1. Okay, well, it's 2 units long and has an area 1, so the area is base times height, so 2 times the height is 1. The height must be a half. So check it out, a half times 2 is an area of 1 for that whole rectangle going from here all the way over to 5. Okay? Finding probabilities for a uniform distribution then really just comes down to computing areas of rectangles. Okay? So the probability that X is less than 1.25 is really just the probability that it's between 0 and 1.25, which goes from 0 here to 1.25 here. And the height is 1/2 throughout the entire interval. So that's a constant height. That makes that shape a rectangle. And it's just base times height. So the base is actually 1.25. The height is 1/2. Multiply those together, and you get 0.625, which is that probability, which is the same as that shaded area. Probability that X is greater than 1.5, you go from 1.5 up, in this case only up to 2. And we shade this rectangle right here and compute its area. Well, its area is base times height. The base is 2 minus 1.5, or a half. The height we said was a half all the way across. So we multiply those together. We get a fourth, or 0.25, for that probability, which is that area. So that's an example of a uniform distribution.